The height of women ages 20 to 29 is normally distributed. Okay, they said normally distributed. Guess what I'm opening? I'm going to open up my StatCrunch normal calculator, or you should be getting your standard normal table from back of the textbook. StatCrunch refused to connect. What? I may have to just open it from, I had a tab opened already, so maybe it would just use it. All right, I'll use this one. Let me have to sign in real quick. That is my email address. Okay. With a mean of 64.7 inches, let me move my, or I'll try to highlight this and then move my mouse. And assume standard deviation of the population is 2.4 inches. That's what this symbol means. Standard deviation of the population. So what we got is we got a normally distributed population with the mean of stat calculator normal. Let me open it first, okay? Maybe I can separate this tab so that I can show both at the same time. Screen, where's the homework tab? Right here. They say mean is 64.7 and standard deviation is 2.4. Got it. Are you more likely to randomly select one woman with a height less than 66.6 inches? I know how to find that. But they're asking more. Or are you more likely to select a sample? Oh, sample of 15 women with a mean height less than 66.6 inches. They sound almost the same, don't they? But they're asking different things here. The first part is asking selecting one woman. Okay, selecting just one woman. And the other one is about you're going to pick 15 women and then take their average. First part is regular normal distribution. So I'm just going to do the first one here, and I will compare the numbers later. They did say height is less than, what was the number? 66.6. I can compute that real quick at 78.6%. They did say round to 4 decimal places, so let me copy that much, and I will put it here. So if you are selecting just one person, then you do the normal, normal distribution, normal distribution. You just do the regular thing. But this is from section 5.4. This is the section where you guys learned about standard sampling distribution of sample means, how samples vary, right? So let me give you the formula. Let me point you to the right formula. 5.8, that's not it, that's the syllabus. 5.4. Let me search for 5.4. Sampling distributions and central limit theorem. If you go down to slide number, where are you? There's a properties. Right here. Slide number 7, you will find that the mean of sampling distribution of sample mean is equal to the population mean. So what that means is on my StatCrunch calculator, I'll keep the mean exactly the same as 64.7. But notice standard deviation is populations. I'm sorry, let me go back. I'm pointing at this formula right here. Let me go ahead and click on it. Notice how the formula is population standard deviation divided by square root of n, right? So we need to find it. We need to find the new standard deviation for this sampling distribution. So what I will do is, I know what the top of the fraction is. That sigma, they gave it to us as 2.4. And we also, I think they gave you that we're picking a random sample of 15 women, right? So n is 15. I need a Desmos or just I'm going to go ahead and open up Desmo's scientific calculator so that I can find the new standard deviation of sampling distribution, and we just call it standard error, okay? Fraction bar, on top of the fraction, let's put the population standard deviation, which was 2.4, right? 2.4. 2.4 is on top of the fraction. In the bottom of the fraction, I need to do square root of n. Square root of n was, let me point it to you one more time, a sample of how many women? Sample of 15 women. So n is 15. We'll plug in n equals 15 here, and I will hit enter. The standard error that we should use is 0.619. I'm just going to go ahead and copy the whole thing because I want to be as accurate as I can. Okay, I copied the whole thing. I went to the StatCrunch, and this is a new standard deviation. They have the same mean, but they have different standard deviation for the sampling. So if you're picking more than one sample, okay, if you're picking more than one, like if you're doing 40 people or 30 people, if you have a sample size, then you have to use this formula, okay, to find your standard deviation. I think they're asking for the same thing though. Like, what is the chance their mean height is less than 66.6? So what I will do is I'll go ahead and just click on compute because it is set as less than or equal to 66.6. No, look at that. The answer is 0.9989. So that's much higher. That's much higher. Go ahead and check answer. And I'll go ahead and tell them, are you more likely to randomly select one woman with a height less than 66.6 inches? Or are you more likely to select a sample of 15 women with a mean height less than 66 inches? And the answer is the second one, because remember, we now need to compare these two probabilities. 78%, like 79%, and almost 100%. So we know it's more likely to select a sample of 15 women with a height that is less than 66 inches. Let me go ahead and click on it, which one is saying it. It is more likely to select a sample of 15 women with the, it's so wordy, but it's true because it has higher probability. So I'm going to go ahead and check answer. And that is it for this problem. So I think the hardest part is figuring out this part right here. But remember, I use a scientific calculator to find the standard deviation of the sampling distribution. And I'm sorry about the noise in the background. And use that as a standard deviation in my normal calculator. I hope this was helpful.